right. Okay, let's go ahead and get started. And today we are going to kind of learn this brand new thing here that you guys have never heard of before. This thing is called logarithms. Okay, logarithms. I'd say it's kind of a scary word for sure. A lot of people don't like logarithms. A lot of people find them kind of confusing. I would argue that a lot of teachers don't explain them very well. And I hope and think, based on my experience, because I've been teaching these logarithms for a long time, that I can do a better job than most other teachers. So I would say you guys are fortunate that I'm here to explain it to you, because I think I have a good kind of process for explaining these. So make sure you listen up here, because I think we're going to make these not so hard, okay? So if you hear other people that in other classes or other schools are like, man, I know I hate logarithms, I never understood them, you can just think, oh, that person must not have had Mr. Barry to explain it. At least that's in what I think in my mind, okay? Okay, so the big idea, and this is like our intro to logarithms section today, and we're going to keep talking about logarithms a lot here. So the big idea on logarithms is that a logarithmic, and we're going to be talking a lot about equations today. So a logarithmic equation is just a different form of an exponential equation, okay? And so we see these first four questions right here. These are all what I would call exponential equations. So you can see we talked about how there's a base with an exponent and then it equals another number, correct? And so that's an exponential equation. And so our goal for these to start today is going to be to rewrite them in logarithmic form, okay? Then these ones down here are actually, these are in logarithmic form, and they always abbreviate logarithmic as log. So these are in log form or logarithmic form. And these ones we're going to want to rewrite in exponential form. So we need to know how to go both directions, okay? Sometimes the exponential form is more helpful for us, and so we would want to be in that form. Sometimes, though, we're going to see many times where the logarithmic form is actually more helpful for us. It makes the equation actually easier for us. And so that's why we would want to do that, okay? All right, so first note, we got to learn like the process for how to actually do this, how to rewrite it in the other form. And so here's how I'm going to explain that, okay? So I'm going to first write an exponential equation. So let's write down this exponential equation. I'm going to say b to the power of x equals y, okay? B to the power of x equals y. So I used variables for this one, okay? And I very intentionally labeled this one right here with b, because this one is very important to us. I've been calling this thing that holds up the exponent throughout last section. I kept referring to this as the base, correct? The base is the number or the variable that holds up the exponent. And so like on this case, the base is b, which I called b intentionally. On number one here, you can see our base is 2. On number 2, our base is 3. On number 3, our base is 4. And on number 4, our base is 9, right? So we can see all of our bases there, okay? When you're changing from one form to the other, the little note I would make here, actually, no, I'm not going to write that down yet. Hold on. Let's switch it to the other form, okay? So now we're going to switch it into logarithmic form. So when I'm switching into logarithmic form, okay, first of all, I'm going to write the word log. So log is always an abbreviation for logarithm, but logarithm, long word to write, correct? Log, a lot shorter word to write, so we just abbreviate it, log. Now, every log has what's called a base, okay? Every log has what's called a base. Now, a base on a log, and I'm going to scroll down here to numbers 5 through 8 here. The base on a log is written as a little, what we call subscript. Subscript is like little letters or numbers that are below the normal level. They're smaller and down below, okay? Call it subscript. And so in this case, the base of this log right here is 5. The base of this log is 4. The base of this log is 2, okay? So we're going to get back to those in a minute, but that's how it's written, as a subscript, a small letter or number that is below the normal ones, and it's right after the log. Well, when we're switching forms, guess what the base of the log is going to be? Well, it's actually going to be whatever was the base of the exponent. So the base of the exponent becomes the base of the log. It's very important to understand, to identify the base of the log, because different log bases produce different results. So we just need to make sure that we're really careful when we do this, that the base of the log is from the base of the exponent, okay? Okay, next up, we need something that's like inside of the log, okay? Technically, this is inside of the log right after here. This letter or number will be written as kind of a normal letter number or number. So you can see here, this one is like after the base of 5, they wrote a regular 125 here, right? It's not an exponent of 125, it's just a regular written number after the base, okay? And what that is gonna be is, in this case, it's gonna be y. So the number that was all by itself over here is now inside of the log, okay? Then we always write an equal sign. And then what's over now all by itself is x. So what was in the exponent is no longer an exponent, it's just a normally written number. So our result here in the logarithmic equation, we have no more exponents, okay? The exponential equation, we have an exponent, and that makes sense because it was an exponential equation. Of course, we need an exponent in an exponential equation. In the log equation, though, we don't have an exponent in most cases. We do have a log, okay? Okay, so my kind of keys here, my 2 steps to doing this switch is, the first step is the base is the base. And I know that sounds like redundant here, but the base kind of means something in the 2 different forms, but it's the same number, it's the same variable, it's the same aspect of it, okay? So in the exponential form, the base is whatever's holding up the exponent. In the logarithmic form, the base is the little subscript in between the right after the log and right before what's inside the log. But when we're switching back and forth, the base is the base. The second thing I always say for these is the base gets a new partner. The base gets a new partner. And I, of course, ran out of room for that. So let me do this. Partner. The base gets a new partner, okay? Let me tell you what I mean by that, but I'll give you guys a second to write that down. So just number 2, the base gets a new partner. And that's it, just 2 steps. I'm gonna explain step 2 a little bit more here in a minute, but 2 steps. The base is the base, but it gets a new partner. So what do I mean by that? Well, if we look back at the base right here, I would say the base's partner is x, right? The base is with x, and then y is all by itself, okay? But what I'm saying is that when we switch it, the base is the base stays the base, but the base doesn't want to be with x anymore. It's sick of x, okay? This is kind of how my dating life went in my early 20s as well. Like I would, not want to be with somebody, so I would leave them, right? And so I'll find a new partner, right? So who's available to get with the base? Well, y is available, y is single over here, right? And so since the base gets with the new partner, the base gets with y, who's all by themselves? Well, your x, right? Haha, get it, your x. All right, so your x is all by themselves now. All right, so then we also need to know how to kind of switch back into the exponential form as well. So if we're going back to the exponential form from the log form, well, you can do the same kind of trick here, the same 2 steps. The base is the base and it gets a new partner. So if I'm going from this log form back to exponential form, I know the base of my exponent is going to be b, but I know that base needs a new partner. So now it's sick of y. It doesn't want to be with y anymore. It wants to get a new partner. So who's available? Well, now his x is available. So he's going to get back with his x. And now y is all by itself, okay? So you can see we kind of get back where we started, right? We normally wouldn't do that, like switch it one way and then switch it back, but we're going to go either from log to exponential or from exponential to log, okay? So we need to know both directions. That's why I did it both directions there. Awesome. Okay, so that's our process now. So now let's practice it with some actual problems here. So we're not actually kind of solving these right here. All we are doing, as you can see, is that we are rewriting them in the logarithmic form, okay? So this literally takes us one step, all right? So not a lot of steps, but it's gonna kind of be a little challenging new thing for us. Later on, we're gonna use these logarithms as like part of a bigger problem. So it is gonna get trickier than this as we move on, but for now, it should be pretty simple, okay? So we wanna write this in logarithmic form. So the first thing I'm gonna write is the word log. My log needs a base, so I need to write a little small number down here, okay? So what is the base? Well, the base is the base, right? So what was the base of the exponent is now the base of the log. So that's going to be a little 2 down there, all right? So that's coming from the base of the exponent here, which was 2. Now, 2 wants a new partner, correct? It doesn't want to be with 2 was with 6 over here in the original question. It doesn't want to be with 6 anymore. So who's available for 2 to get with? 64. So 64 is written as a regular number after the log and the base. So we have log base 2, and we would read this as, we would say log base 2 of 64 equals, all right, and then who's all by themselves? 6, right? 2 didn't want to be with 6 anymore, so now 6 is on its own side of the equal sign, and that is it. We are done. For those of you who hate showing work, you probably love this these problems because that's literally all we do, okay? All right, I'm gonna try it one more time here. Why don't I do number 3 next, and I want you guys to try 2 and 4 without me. We will go over them, but I just want you to try. So number 3, it looks scarier because we got some fractions going on, but it's really not. Okay, it's really the same idea. So we're switching it to log form. So I'm gonna write the word log. We need a base here. So what was the base of my exponent is now the base of my log. So that's gonna be base 4. 4 wants a new partner. 4 was with -3, but he doesn't want to be with -3 anymore. So who's available to get with? 1 over 64 is available to get with them. So that's going to go right there. Kind of just written as a normal sized fraction there. Then we draw our equal sign. And then who's all by themselves now? -3 has no one to be with. So that's all alone on its own side of the equal sign. That is it. We are done. See, this is not too bad. We're just shuffling stuff around, right? And we're writing the word log. That's kind of the new thing we're introducing into it, okay? All right, I'm gonna pause for like 2 minutes because that's more than enough time to do numbers 2 and 4. Actually, it's not even gonna be 2 minutes. I'm gonna pause 1 minute because that's enough time to do number 2 and 4. So you guys try them out and then we'll go over them together. Ready, go, 2 and 4. All right, if you're all done with 2 and 4 and you think this is easy, why don't you guys write in the chat if you think it's easy? You can just put the word easy or fácil. All right, thank you. Let's see. All right, thank you, Pablo. Cool. All right, so let's go over our answers here, make sure we did them correctly, even if you thought it was easy. So here we go. To write the word log, we need a little small base at the bottom, so that's gonna be 3. 3 wants a new partner, so it's gonna get with 27. And then the 3 that was in the exponent is now isolated, so that's that. And then lastly, number 4 here. So we have log, the base is gonna be 9. New partner is gonna be 1 over 81, which means that -2 is over there by itself. Boom. Okay, so now let's move on. Now we're gonna do the same thing, but kind of the other direction. So now the questions are coming in log form, and we're going to switch them to exponential form. So we're still just rewriting. It's just that like the answers from our last set look like the questions here, and the questions from our last set are going to look like our answers here. That's just the other way around with it. But we can use our same trick, okay? So the base is the base, and it gets a new partner, right? So first of all, if I'm going to exponential form, I'm not going to write the word log anymore. Like we're leaving log form, so we're not going to write log. I'm just going to write a base with an exponent, right? So what's my base? Well, the base is the base, right? So my base is going to be 5. It's now written as a normal size number, but it gets a new partner, right? So 5 doesn't want to be with 125 anymore. It wants a new partner. So it's going to get with 3 because 3 is available. Now 3 is going to be the exponent, okay? Because this is an exponential equation, it needs an exponent. And so the new partner will always be an exponent. And then so 5 was with 125. It doesn't want to be with 125 anymore, which means that 125 is over here all by itself. That is it. We are done. Is this an exponential equation? Yes, it has an exponent, right? 5 to the 3rd power. Is it a logarithmic equation anymore? Not anymore, right? We left log form. So it's a good thing we did not write the word log. The log was in the question, right? And our answer has the exponent. Okay, let's check out number 6 then. Same idea. So we're going to write an exponential equation here. We need a base. So our base is the base. So the base of the log is 4. I'm going to write a 4 right there, normal size 4. It needs a new partner, so it doesn't want to be with 1 over 16 anymore. The new partner is going to be the exponent now. So -2 is going to become the exponent, which means 1 over 16 is going to be all by itself there. So there we go, rewritten as an exponential equation. All right, let's do it again. 1 minute here. If you want to try numbers 7 and 8 on your own, I'll go over the answer in 50 seconds. All right. Let me give you 20 more seconds here. Okay, so let's go over our answers here. Number 7. So first of all, the base is going to be 2. New partner is -5, so that's going to become the exponent. There we go. And then that's going to equal 1 over 32. Since 2 doesn't want to be with 1 over 32 anymore, it's now all by itself, okay? All right, and then last one here. So my base of my exponent is going to be 4. The new partner is 3, so 4 to the power of 3 equals 64. There we go. Okay, awesome. So now we're going to shift gears a little bit here. Okay, it's the same basic idea, but we're going to evaluate these expressions here. All right, so evaluate each expression. What that means is that these are usually going to be here a number answer. Okay, so we have to figure out what is this, okay? What number is log base 4 of 64, okay? And so how we're going to solve these ones, so this, or I should say, this is not just asking us to rewrite it in the other form, all right? It's asking us for an actual number answer. The previous 2 sets did not ask us for an actual answer. This is asking us to rewrite it. So this one asking for a number answer. And so what I would always do for these ones is I would say, okay, well, it's got to equal something, right? Why don't we call it X? Could we call it A or B or whatever we want? Yes. I'm just going to label it X, okay? So log base 4 of 64 equals something, and I want to know what that something is, right? Well, now that I've made it equal X, I've now made this a logarithmic equation. And so now what I'm going to do is I'm actually going to switch it to an exponential equation, okay? So the exponential equation, well, what would that look like? Well, thinking back to our last set, we would, the base of it would be 4. The new partner is going to be x, which means that 64 is all by itself, right? So it's saying 4 to what power gives me 64. All right. Now, some of you may know this off the top of your head, and if you do, that's great. If you don't, though, this is where I would get the calculator. So let's check out the calculator. So I think most of us know that 4 to the second power is not 64, correct? 16. All right. Well, what about, it's got to be bigger than that, right? So let's try 4 to the third power. Boom. 64. So what does x have to be here? I would say x has to be 3. In order to make that work, I have to do 4 to the third power to give me 64. Am I allowed to use a calculator to help me out with that? Absolutely yes. Okay. All right, so let's try this again with number 10 then. So once again, I'm going to have this equal x equals something, some variable, whatever you want. And so now it's going to look like 2 to the power of x. So the base is 2. The new partner is x equals 1 over 8. All right, this one's a little trickier here, but that's okay. We can do it. I want you guys to remember here, and I think we did talk about this, okay? I'm going to make a note here. I'm going to remember that a negative exponent creates a fraction. A negative exponent creates a fraction. It drops the number down to the bottom. So I kind of already know in this case that x is going to be negative, okay? Because it creates that fraction over there. So in this case, I know that 2 to the third power gives me 8. That's an important fact here. So the answer is not 3, correct? Because if it was 3, it would say 2 to the x equals 8. But since that 8 is on bottom, that tells me that x is just negative 3. Because the negative drops it to the bottom, and then the third power turns it into an 8. So this one will be negative 3. Are we allowed to double check that answer on a calculator? Absolutely yes. Let me show you how to do that. So if I said 2 to the power of negative 3, now it would actually give me a decimal here. Could I go down here and type, well, what's 1 to 1 over 8? Is that the same decimal? Yes, it is, right? Or actually, if you're working on Desmos, if you press this button over here, it gives you your answer as a fraction. You can switch back from like fraction to decimal here. So that's pretty cool. I like that button. So you can see that it is in fact 1 over 8, okay? Awesome. All right, let's move on here. All right, so we got a few more. Yeah, we should be able to get all of these done because these are pretty quick, especially now we really know what we're doing. All right, so we'll make number 11, we'll make that equal x again. So this is going to look like 7 to the power of x equals 1. Now this one is actually kind of a special one as well, so I'm glad we're doing it together. Does anybody know there is actually an exponent that turns everything into 1? Does anybody know the magical exponent that turns everything into 1? Good job, Danny. Yes, 0. So x equals 0. Wait a minute. So then whatever the base is down here, if this is a 1 right here, is the answer always going to be 0? It actually is, because if you think about it, Even if this, let's say this was an 8 right here and that was still a 1, it would say 8 to the power of x equals 1. Well, that's still 0, right? Because 0 turns everything into 1. If it was a million here, log base 1 million of 1, it would be a million to what power gives you 1? It would still be 0. No matter what that number down is there for the base, if you have a 1 inside, that's always going to come out to 0. Are you allowed to double check this on the calculator? Once again, the answer is yes. 7 to the power of 0, you can see, is 1. So if you ever are not sure, go ahead and type that in the calculator. All right. Number 12, I think, is actually a pretty easy one. So let's check that one out. We'll just switch it to x, or set it equal to x, and then switch it to exponential form. So the base is 2 to the power of x equals 2. So 2 to what power gives you 2? Like I said, I think this should be an easy one. This one is going to be the first power, right? So this is actually a rule as well. Whenever your base and the number inside are the same number, your answer is always going to be 1. That makes sense because, like, if these numbers are the same, when you set it up like this, it's saying, I don't really want to change that number. I want to keep it the same. And we know that 1 is the exponent that always keeps it the same. So there's shortcuts for both of these if you can remember those. If you cannot remember them, I think that's fine. Just kind of do what we did here. All right, let's check out number 13. So for this one, we'll equal x as well. So then the base is 3 to the power of x equals 81. So we need to find what power turns 3 into 81. Once again, some of you may know. I know this one off the top of my head, but if you don't, let's go ahead and use the calculator for that. All right, so let's try, I think we all know 3 to the second power, that's 9, right? So that's not big enough. So what's the third power? That would be 27. 3 times 3 times 3 is 27. So that's not it. What about the fourth power? Ding, 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 ding. There we go, 81. So our answer here is going to be 4. All right, next up, we got number 14. So we'll set that equal to x as well. So we have 7 to the power of x equals 1 over 343. So we see that this exponent created a fraction here. So already I know on this one, I know x is negative, because anytime a fraction gets created, that's a negative exponent, right? What negative exponent? Well, I just need to figure out like what power turns 7 into 343. I would guess that it's the third power. Let me just check it out though. So we know 7 squared is 49, right? So that's not it. So 7 to the third power is in fact 343, which would mean 7 to the negative third power would be 1 over 343. Just remembering that that negative exponent flips it upside down, right? As a fraction, okay? Okay, so then we know here that x is negative 3 because we got that fraction going. All right, 2 more, and these are very important as well. So make sure you listen up here because these are a little weird, right? What's weird here? There's no base, right? They didn't write the base. So this is actually not a mistake. This is actually, this does happen, okay? And so I want you to write down here, invisible base. When there is a log written with an invisible base, the base is always the same number, and that base is 10. If you've ever looked on a calculator, do I have one here? Yes, every calculator actually has if you look at a scientific calculator here, they all have this button right here. And now you can see it at the log, right? Yeah, log. And if you type that log button, there's no base written. So when we use a log on the calculator, there's no base written. This is actually a log with a base of 10. So all calculators have a base of 10 on their logs. So now, for our purposes here, what we're going to do today, I still want to set this equal to x. So when I switch this, I do the exponential form. My base is going to be 10. It doesn't want to be with 1,000 anymore, so it's going to be with x. And 1,000 is going to be all by itself. So when you write it in exponential form, we're not allowed to make the 10 invisible anymore. The 10 is allowed to be invisible, and actually it should be invisible for logs, but for exponents, we need to actually write it, okay? Now, the reason we like, the reason that the invisible base is 10 is because 10 is like a very popular base for exponents. And the reason that 10 is so popular is because 10 is actually the easiest base, I think, to work with. Because there's a good trick for powers of 10. If you want to know what power of 10 is, I actually don't need a calculator for this. Because if you have a number like this that starts with a 1 with a bunch of zeros, the power of 10 that it is just how many zeros are there. And there are 3 zeros, correct? So that kind of also, so we know like 10 to the first power, that's a 1 with 1 0, right? 10 squared is 100, so that's a 1 with 2 zeros. 10 to the third power is a 1 with 3 zeros, and so on, right? And I would also point out, what's really cool is it actually also works for the 0 power, because that's a 1 with no zeros after it, right? Because we know the 0 power turns everything into 1. Look at that. That's so cool. All right, so el último now, last problem. Set this equal to x. We know it has the invisible base, so we know the invisible base is 10. So 10 to what power is going to give you 1 over 100? Well, sabemos, we know that x is negative here because it created a fraction, right? So anytime we get that fraction, we know x is negative. So negative what? Well, if we have 100 down there, how many zeros are there? There are 2, so that is 2 zeros. Are you allowed to go double check this on the calculator? Of course you are. The answer to that keeps being yes. So you can see that does give us that 1 out of 100 when we do the negative 2 power, okay? Awesome. That's logs, everybody. Not as scary as everyone makes them out to be. You just got to kind of get this pattern down of the switching, okay? So let's make sure we submit these notes. Today. Tomorrow, Wednesday, make up any missing assignments that you have.